In this lesson, we're going to learn how to sketch the graphs of transformations of tangent and cotangent functions. In order to start with, we need to sketch the graph, the basic graph of tangent and the basic graph of the cotangent. And in order to figure out what these graphs look like, we can start just exactly the same way as when we were trying to figure out how the graphs of sine and cosine look like. So we can just make a table of values. And you could use any angles, but special angles are good for this purpose. And you make a table of values, you list here a bunch of special angles, and then you evaluate it. Okay, using you can use the formula sine over cosine, tangent equals sine over cosine, and then plug those in, and then you get the corresponding values. Tangent of x is undefined when x equals negative pi over 2, because tangent is sine over cosine, and cosine of negative pi over 2 is actually 0. So you will be dividing by 0, and you cannot divide by 0, so that's undefined at that point. And for the same reason, tangent of pi over 2 is undefined. And for all the other points in between that are special angles, we get these values. Okay, so you take these values and you plot them, and this is what you will get. So you would get this shape that is like an S shape, and you see that the graph actually goes up and up and up and up. And this, what happens at negative pi over 2 and pi over 2 is that you actually have vertical tangents. Okay, the graph of tangent gets arbitrarily close to that vertical line x equals pi over 2, and to that vertical line x equals negative pi over 2. So those two are asymptotes. And the graph of tangent, as we have already mentioned before, has period pi, so that means after every pi, this thing repeats itself. All right, so you have that, and then it repeats here infinitely many times to the right and infinitely many times to the left. And we can take as a basic period the period between negative pi over 2 and pi over 2. If you only memorize 3 points, that's good enough. The main points that we're going to memorize should be, the ones that I recommend, is the value at 0. The value at 0 is 0. Okay, tangent of 0 is 0, right there. The value at pi over 4, or 45 degrees, tangent of pi over 4 is actually 1. So that's easy to remember. And then the value at negative pi over 4 is negative 1. So 1 and negative 1. So that's not hard to remember. And if you remember also, we had mentioned before that tangent is an odd function, and that means that it is symmetric about the origin. So it is symmetric about the origin. All right, so that's the basic shape of tangent. You could also make a table of values for cotangent and plot the results, and here's what you would get for the basic graph of the cotangent. So it is actually very, very, very similar. The graph is basically the same, but it's like flipped. And so if these ones like go up, these ones go down. So the tangent is increasing in each period. The cotangent is decreasing in each period. And you can take as the basic period the period between 0 and pi. So you can take that as like the basic copy, and all the other ones are a copy of that one. Cotangent also has period pi, so after every pi, you get a repetition. Okay, and you can take as basic points the values at pi over 2, which is 0, and then the value at halfway between 0 and pi over 2 would be pi over 4, so the tick mark right there would be pi over 4. The value at pi over 4 would be actually 1, and that's because the cotangent is the reciprocal of the tangent. So the reciprocal of 1 is 1, because the tangent of at pi over 4 is 1, and the reciprocal of 1 is 1. So the cotangent of pi over 4 would be 1. And then here, between pi over 2 and pi, the tick mark that is exactly halfway would be 3 pi over 4. Okay, so the tick mark there would be 3 pi over 4. I don't really have enough space, so I'm just going to do this. That tick mark, all right, is 3 pi over 4. And the corresponding value at that, over that tick mark, or below that tick mark, would be negative 1. Okay, so this is 1 and negative 1. I don't have enough space there, but I will clutter it, but that's negative 1. Okay, so remember these three, so you see is almost exactly the same as tangent. So you should remember 0, the tick mark over pi over 4, which is the value is 1 at that point, and the 1 over negative pi over 4. Again, I don't have space there. The value at negative pi over 4 would be negative 1. Negative 1, 0, 1 for the y coordinates. Here is the same y coordinates but in reverse. 1, 0, negative 1. Okay, so remember those basic shapes, and we should be able to use that to sketch graphs. All right, and before we give the first example, here are the basic properties of a transformation of a tangent function. We're going to start by drawing tangent functions. Then we're going to give an example of cotangent functions. And actually, you draw them exactly the same way. I mean, following the same procedure. All right, so tangent functions, transformations of tangent functions look like this. A tangent of bx minus c plus d, so it's the same shape as a sinusoidal function. Okay, these are periodic with period pi. So the formula for the period is now slightly different. Instead of being 2 pi over b, the period is now given by the formula pi over b. Because in the other case, the sinusoidal case, the original period of sine and cosine without any transformations of any kind is 2 pi. And then you take that, and when you make a transformation, you modify that. So it's 2 pi modified. So the formula is 2 pi over b. In the case of tangent, the original period of tangent is pi. And then you modify the tangent by doing this. So it's going to be pi modified. How? Well, pi over b. Okay, so in any case, in any event, is the original period over b for both formulas. For the tangent, original period is pi over b. For sine over cosine is original period over b. Original period in those cases of sine and cosine is 2 pi. Okay, so 2 pi over b and pi over b. All right, the domain of this tangent transformation is basically all numbers for which x is different from c over b plus pi over bk, where k is any integer, and that's basically because these are the numbers for which the cosine is 0, and if the cosine is 0, the tangent is not defined, okay, because tangent is sine over cosine. So these numbers is where the cosine is 0, so the tangent is undefined. And lastly, the A stands for stretching factor, okay? The D, as before, is vertical shift. That has not changed. The A is now the stretching factor. We don't call it the amplitude anymore because there are no waves. There's no maximum minimum values for the tangent, and there are no waves. So the concept of the amplitude of the wave does not make any sense for tangent. So we don't call it the amplitude anymore. It's now called the stretching factor. And lastly, you could also find the phase shift if you really wanted to do that. And I think the homework might ask you for that, find the phase shift. You can use the same formula as for sinusoidal functions. Okay, the phase shift is equal to c over b. for actually sketching the graph of a transformation of tangent, we don't really need it. You can find it, but it's really not needed. The procedure is slightly different for sketching graphs of transformations of tangent. So what is the procedure? Okay, here's the procedure. First of all, have in mind the basic shape, okay? The tangent, that is the basic shape. And you should remember 3 points. The point at 0, which is 0, the y value. The y value at pi over 4, which is 1, and the y value at negative pi over 4, which is negative 1. That's it. Okay, and where are the asymptotes? The asymptotes is at x equals negative pi over 2, and the other asymptote is at x equals pi over 2. Those are the main details you need to remember. And once you remember that, here's what you really need to do. Is you're going to find, because the basic graph of the tangent is being moved around a little bit, you need to find where the new asymptotes are, okay, for the transformation. Where are those two consecutive asymptotes? Well, to find where those consecutive asymptotes are, you're going to take the inside of the tangent, the bx minus c part, and you're going to set it equal to the left asymptote, which is negative pi over 2, and you're going to solve that equation. And then you're going to do the same, take the bx minus c and set it equal to the right asymptote, which is pi over 2. So you're going to take the inside, set it equal to negative pi over 2. That is going to give you one asymptote. And you're going to do the same, but for the other asymptote, which is pi over 2. You're going to solve these equations, and that's going to give you the two consecutive vertical asymptotes, which is where you're going to draw one basic period for the transformation. Okay? And once you find your first left asymptote and your right asymptote, what you're going to do is you're going to divide the interval into 4 equal pieces, and that's really something that we always did for drawing sinusoidal functions, so that is really actually the same. And then you're going to chase around their points and plot them where they're supposed to be by doing the times a plus d, times a plus d for the y coordinates. So that is also the same as before. And then connect the points following the shape you know your graph is supposed to have. All right, now we are ready. So let's draw the first example. Sketch the graph of one period of the function f of x equals 0.5 tangent of pi over 2 x plus 1. Okay, let's find the basic properties of this thing. So you could find the period. The period is, the formula is pi over b. Okay, so pi over b in this case means pi over, and the b is pi over 2. And then we simplify this. What do you get? We get pi times 2 over pi, because dividing by something is the same as multiplying by its reciprocal. You can cancel the pi's and you get 2. So the period of this thing is 2. You can find the stretching factor. You don't really need this, but they might ask about it on the homework, so let's do it. So absolute value of A, this is absolute value of 0.5, which is 0.5. Again, this is a stretching factor. So in this case, actually, because it's less than 1, it is called the compression factor. So absolute value A is either a compression or stretching factor. So the graph is being shrunk a little bit. Shrunk. Okay, and lastly, we need the phase shift, and then we need to find two asymptotes. So the phase shift, we're not going to need it. We're just going to do it to be complete. So phase shift is C over B. What is that? Well, the C is 0, and the B is pi over 2. So the phase shift is 0, meaning no phase shift. There's no horizontal shift. Okay, now finally let's find two consecutive asymptotes. Two consecutive asymptotes. Once we do this, we'll be good to go. We'll be ready to sketch our graph. All right, let's find two consecutive asymptotes. So what is the procedure for that? You take the inside of this tangent and you set it equal to the left asymptote. So we take that, we set it equal to the left asymptote. The left asymptote of the basic period is negative pi over 2. And then you do the same, and you set it equal to the right asymptote, which is pi over 2. And then you're supposed to solve these two equations. Okay, solving this equation, dividing by pi over 2, well, the top is equal to the bottom except for that negative, so you get the answer is negative 1. And then here, you do the same. So x is equal to 1. So the two consecutive asymptotes are negative 1 and 1. Okay, another way, as I mentioned here, another way of doing this is you can just solve one of them, the left one, and then add the period, and that automatically gives you the other asymptote. You don't have to solve both of them. You could, that's one way. The other way is you just solve one, the left one, and then add the period, and that gives you the other one. So for example, here, this one, we solve the left one, we get negative 1, and if we add the period is 2, negative 1 plus 2 is actually equal to 1. So that gives you the next asymptote because that's the period, right? This thing is going to begin again after a period of pi. So that's the beginning, then the end of that graph is, or the basic part is pi units later. The period units later. In this case, it's 2. All right, so we have everything. Now let's sketch a graph. So let's draw our axis. There. Okay, we're going to have an asymptote at x equals negative 1, and we're going to have the other asymptote at 1. So let's then draw an asymptote at 1, let's suppose that's 1, and the other one at, that's negative 1, and the other one at 1. Okay, so let's say that's negative 1 and that's 1. Okay, it's supposed to be symmetrical. My picture is not too good. This looks a little thicker. They're supposed to be the same, but all right. This doesn't have to be perfect. All right, then that's it. Now let's chase around our points. I like to start from the center. Okay, so we're gonna chase around the 3 points, the 0, 1, and the negative 1. Okay, I like to start, as I said, from the middle. So the middle points, and before we do that though, we do have to divide that interval into 4 equal pieces. Right now it's divided only into 2 equal pieces. So divide it into 4 equal pieces, we're just going to divide this one in half and in half. So this one you would have 1/2, which is the number halfway between 0 and 1, and this would be negative a half. Okay, now let's do it. So starting from the middle, the y-coordinate of that middle point is 0. So times a plus d, 0 times a, meaning times 0.5, is 0.5 plus d, sorry, 0 times 0.5 is 0, plus d plus 1 is 1. So that means the y-coordinate is actually 1. So over the middle take mark, we get a 1. Okay, let's suppose that's 1. Okay, y-coordinate is 0, times 0.5 is 0, plus 1 is 1. Now, next, let's do that for the y-coordinate of the point that is over the second tick mark. This one, the one left of the center. So the y-coordinate of that point is negative 1. So negative 1 times 0.5 is negative 0.5. Negative 0.5 plus 1 is positive 0.5. Okay, so it should be around here. And lastly, the y-coordinate of this point, the one above the fourth tick mark, is 1. So now 1 times 0.5 is 0.5 plus 1 is 1.5. So 1.5, so let's say that's 1, and that this is 2. So 1.5 would be around here. And now we connect them following the shape that we know that our graph is supposed to have, like a curvy shape. And then we're done. So let's connect them. Curvy shape. Okay, there we go. That's the graph of time of this function f. And of course, you know that this is supposed to repeat itself infinitely many times. This is just one period. This repeats itself infinitely many times to the right, infinitely many times to the left. Now, this on the test and on the homework, this is usually multiple choice. You don't actually have to draw it yourself. So what you do is just choose the graph that satisfies these properties. Make sure that the graph you choose, in this case, if this was a problem, I would choose a graph that had over 0, the value is 1, over 1/2, the value is 1.5, and over negative 1/2, the value is 0.5. And that it has asymptotes at 1, negative 1, and an asymptote at x equals 1. So make sure that it matches all those properties, and then you're done.